Hello everybody, I'm Callum at Repair Wins, and I've got another episode of Fixes in 5 for you today, provided I'm actually able to fix the thing and edit it down to around 5 minutes. It's an angle grinder, and a really cheap rubbish one, but I think it's from the late 1990s. It's my own tool. I bought it second hand, I used it a few times, and I went to use it the other day. It's just making crackling noises and it sounds like it's ready to go pop at any moment. I'd plug it in and demonstrate, but I really don't need it to go bang because then I'm going to have problems to deal with, aren't I? So I think without any further ado, we'll just see about getting this thing taken apart. Fingers crossed it's not too difficult. And once we've gotten it apart, let's take a look and see if we can find what the problem is. I remember that when I bought this, I replaced the plug that was on it, and I also replaced the wire. And from memory, it is just a case of taking this one screw out, and that'll then free up the back cover so I can get access to the wires. Yeah, that should come off. I just need to cut this zip tie that's on here. Upon second thoughts, I probably shouldn't have put those on there, but the sleeve was cracked and I didn't want it to cause trouble. Right, so it looks absolutely, ooh, that is actually pinched quite hard. Maybe I shouldn't have put that down with so much force, or maybe I should have found something to go in the gap. I think we know what the issue is here, that this is pinched too tightly. Bad news, as soon as I opened it up it just went snap. Hopefully that's not going to be a big problem, although I can kind of see it being one. And yeah, look, I've managed to crush the life out of that. You can see how flat it is. If we're looking for positives, I can see the brushes are nice and accessible, which is a good thing. I just need to take these two screws here out, which I can do by putting a flathead screwdriver in at a bit of an angle. We'll remove this wire, and then we'll see if the crackling goes away when I put a new wire on there. It's really regrettable I didn't get this on camera, but look. As soon as I put the screwdriver in, I heard a little click and the screw started coming free. I thought good news, so I just broke the one on the other side free. I noticed it was fairly loose. And yeah, those pins have all corroded, or they've snapped off or something. And if you're thinking, oh, we'll just solder the pins back down, well, look. They go through to the other side, and this is held in place with epoxy resin. Right, and I can scratch it, but there's not a chance in hell that I'm going to get this out of the epoxy. I don't think this one's going to be repairable, I've got to be honest. Unless I can figure out where these wires were running to, and then potentially somehow manage to solder onto here. But then I've also got this to contend with. So I'm going to have to go away and do a bit of thinking here, I think. I have a possible plan of attack. So we obviously got this wire here, and on the other side we have another one. I think in theory this tool will work fine if I was to snip this, snip that, and then basically solder some mains cable to here and run it back up the top, and you already know the story. My only concern with doing that is that we'd then be bypassing this mains capacitor, and it's not the end of the world to bypass it, because all it's doing is stopping interference and going back onto the, onto the mains. But whilst it's not essential, I'd rather not bypass it unless I really don't have another choice. The capacitor inside this tool is 0.22 microfarads at 275 volts. I've got this pack of capacitors here, which is 0.1 microfarads at the same voltage, and that's a fairly wide capacitor, so could I not just put two of these together, and then at the very least we would have basically the same amount of ripple suppression. I don't think it's the worst idea ever conceived, so I might just bodge something together just temporarily to see if my little idea works. I've got an idea. So my plan is, as I said in an earlier clip, just to cut this here, cut that there. I'm going to solder a bit of wire directly to it, or find some terminal blocks. We'll just test if the tool works like that. If it does work, then I'm going to take two of these capacitors, 0.1 microfarads each, 275 volts, and I'm pretty much going to tie them together. And then the idea is that they will replace this capacitor, which is 0.22 microfarads, you can see down there. So it's not an exact match, but this is a cheap, crap, obviously fairly low quality as we've found out, angle grinder. So that's a risk that I'm willing to take. So I'll put them on top of each other as promised, text facing the same way, and I'm just going to grab the pliers, grab the legs, and just twist them together. Not going to do a silly amount of turns, just something that's going to permanently secure them. And I'll do the same for the other side. Grab on, give it a twist, give it another twist, and a third one, I think we can get somewhere with that. I've snipped these wires. There we go. All I need to do is just solder a bit to here, solder a bit to there. We'll plug it into the wall, see if it works. If it does, we'll then find somewhere to bodge my capacitor thing into. If you're wondering how I know which wire is live and which wire is neutral, the answer is I don't. And I did try and use some common sense and infer and whatever, but it really could be either way with how this thing is designed. So all I'm going to do is just chance it. I'll put live here and neutral there. And if it's wrong, all it means is that the tool will spin backwards instead of forwards. And then obviously I'll know. It's part of the reason why we're doing a test. Alright then, so I'm going to get my neutral, spin it up, my live, spin it up. You can see me doing that. And we're just going to... We'll do the neutral first because I've got more access. So if you're a fan of Diode Gone Wild, you'll probably appreciate the dodginess of what I'm doing here. And then I'm just going to twist these two together as well. At least I'm going to try, because this is really thick, heavy-duty wire that I'm adding. And what they put in the angle grinder sadly isn't. Just twist that over the top. It should hold itself in place just for a test. Okay, so I appreciate that's dodgy, alright? I certainly wouldn't use it permanently like that. But we can just plug it in now and we can press the on button, can't we? Here we are then. We've got mains voltage coursing through those wires because I've got it plugged in and switched on. Cool. Now, obviously I'm intelligent enough not to touch anything, but the question is, how do I, if I don't want to touch and zap myself, grab this and twist it, you know, so it's going to switch on? And I don't really know, if I'm being honest. I've just had a dodgy idea. Hold on. I've just done something really daft. I've spun the switch around and clicked it into the on position. So it's now switched on. And I'm having a very good look. And neither of those wires are in any danger of touching anything they shouldn't. So I'm going to go under the desk and press the on button now. And obviously, you know, there's a risk it could fall on me and do some damage or whatever, but that's a risk I'm willing to take. I don't think it's magically going to jump forwards in the half second that it's being tested. And I'll then be able to use the video to decipher which way this wheel is spinning. So, oh god, here we go. It's going to kill me. Just need something to put in the way. Something that's not worth much. This scrap computer motherboard should do the job. It's worthless. If I just hold that there, I'll just switch the tool on. Did that make you jump? Because it made me jump, but we can see the tool's working at least, can't we? My lights haven't switched off either. Let me just show you. Okay, you can't see anything. Alright, we don't need this. They're all switched on nicely. I'm not dead. Somehow my desk isn't damaged, which is unbelievable. Oh dear, we've had a casualty. And obviously I've switched that off, and let me just unplug it. Ugh. By the way, don't try something like that at home, okay? Whilst it might have looked super duper dangerous, I'm at least sensible enough to know to put something in the way and to take cover, you know, and to stand back a little bit. I'm going to watch the clip, I'm going to figure out which way the tool was spinning, and if it was spinning the correct way, then nice, and if it wasn't, we'll just flip the wires around. I think I've been able to work out which way the wheel spun, so, and I've also just realised that if it had been wired up the wrong way, it would have flipped and fallen off of the desk and landed next to me, so yeah, please don't attempt something like this at home, alright? Seriously. These videos, everyone says they're for educational purposes, but if you're stupid enough to do something like this at home and it falls on you, I am not the one who's responsible. Just saying. But either way, this tool was like this, and then it has started spinning, and the momentum is throwing it around like this. And given that it's done that, it must have been spinning to the right. Because if it was the other way, it would have flung it, and the tool would have, you know, the tool would have bounced on its handle. I mean, it might possibly have overcome. But the point is, the blade is spinning this way. So if we just keep that in mind, it's coming this way, this way, this way, this way. Still that way, that way, that way, that way. And, right, so it's going down the way, isn't it? So it's going towards the floor. And if you were to hold the tool like this, which is how you hold it, you're going to want the blade spinning like this to cut stuff. You're not going to want it spinning like that, because that's not going to cut anything. So yeah, I've managed to do it correctly. It was just luck. It wasn't any intelligent guesswork. So we now know then that the yellow is live and that the black is neutral, and we can see about bodging our special little capacitor thing into the mix, and then also about bodging, you know, a power cable in. This cable here is about 30 years old. It came from some old Vax branded Hoover. So it should do the job perfectly because look, we've just got the live and we've just got the neutral. And I think what I'm going to do is kind of solder this up the way that I wanted to. And we're going to put all of the components and we're going to sort of glue the stuff down here because this cover has got, conveniently, it's got a bit of extra room on the inside. So we should be able to get away with finding somewhere to glue this down. Soldering that to there, this to here, and then obviously soldering these wires to there. I think I've come up with something that might just work. So I'm going to get the wire, I'm going to take all of the annoying twist out of it, and I'm going to put it here. Then I'm going to line this sort of up just beyond, you know, the cord grip. I'll fold that back to there, solder it on. Fold this back to here, solder it on. And then when they're soldered together, I'll just stretch the legs on these capacitors out. And I'll solder this here and solder that there. So if I hold this in place, we'll just put this on. And yes, obviously it's broken. We're just using it to hold the wire down, that's all. Right, neat, okay. And then yeah, why shouldn't this work, you know? Now I would obviously put some heat shrink tubing on here, but if I'm soldering the capacitors, then clearly I'm not going to be able to do that. So we're just going to fold that out, try and squeeze this into the gap. Maybe I'll fold this one down a bit first. I'll fold this one up a bit and then we'll marry them together. And if that was to then sit here and I was to fold this kind of, you know, up the way and fold that down the way, we would still be struggling to make the distance that's needed, I've got to be honest. So if I put those there, I don't see any reason why the cover won't close, you know. But alright, let's just get these soldered up and we'll worry about the capacitors in a minute. We're even going to use lead-free solder because a lot of people hate this stuff, but to be honest, if you're just soldering basic wires and stuff, it's absolutely fine. If you're doing micro soldering, repairing PCBs and stuff, it's a lot tougher to use, but after a while you start getting used to it and you realise it's not that bad. Regardless, then I've got my iron set to 370, let's just increase that to, yeah, 395, and we'll just start flooding soldering. Now, don't worry, the smoke won't get you through the camera. I'm the one who's got to breathe this crap in. Right, I'll come off. That's plenty of solder. We'll give it a minute just to cool down before I do the next side. I'm going to fold that on itself a bit more, and then, yeah, we'll come in here as well. Solder, solder, solder. And pull away. Brilliant. We might be able to get some use out of this sad little thing yet. So if I snip that, snip this. There we go, that's going to go in the recycling. And then I can just pull these wires through. Do the same for the other side. We're going to snip off the rubbish bits. There we go. And now I should be able to strip this back a tiny bit, strip that back a tiny bit, solder it here, and then do the same again and solder them to the capacitor. So to make life easier, I'm going to solder them to the capacitors first, and then they can be bent and manipulated more easily. I soldered one side and had success, so I thought I would show you how I'm going to do the other side. And all I intend to do is put a little bit of flux on here. Flux just helps solder flow, not too much. I don't want dust to get like jammed up in the tool. Oh, and looking around this tool, it's obvious it had a very hard life before I ended up owning it. So chances are it was used by some builder or something who knew it was on its last legs and got rid of it. The mug that bought it, that's fine though. I'm here to do a repair, and the repair is what I'm going to do. Although I do occasionally think that even in the third world, people probably wouldn't bother doing a repair like this, so why am I trying? And the honest answer is, I don't really know. But all I'm going to do is lean over. Just need to pinch these two together for a moment. And we'll put some heat into the bad boy, and then fingers crossed. Any second now. There we go, look. I'll hold for a moment, and I'll let go. And I've watched the solder go duller in colour, which means it's cooled down enough so it's no longer liquid. And yeah, they're both soldered up now. So I'll bring you closer. You can see there, look, solid connection. See there as well, solid connection. To be honest, I might not even have to glue anything down. I don't think it'd be a bad idea to grab some epoxy and sort of set it all in place, but that just means that should the wire on this tool need to be replaced again, it's going to be a lot tougher. Although realistically, it's not like I'm going to bother, undoing all of this. I'll probably glue it all down at some later stage, but for now, I think we should just get the back cover on and give it a test. There we are then, ladies and gents. I've managed to get the bottom cover on. Didn't take too much effort at all, just line it up, push it on, screw it in, happy days. It's plugged into the wall, it's switched on. Obviously it's not switched on, on the switch on the angle grinder. But what I'm going to do is I'm going to grab this and I'm going to put it underneath the desk, and when I'm holding it under the desk really firmly, I'm then going to blast it just to see if it wants to switch on. Alright, so I'm going to sit in my chair, going to hold it well under the desk, just make sure, no wires anywhere near, and go. Sounds alright to me. I think I'm going to call that a repair. And I think I'm going to call it a pretty decent repair. This was originally going to be a fixes in 5, but it's definitely going in the device is not worth fixing playlist instead. I'm really, really pleased with this mod. It's soldered properly. I've put a big zip tie around here to hold everything in place. And you can see it still has the brake, but again, come on, this is great British design after all. That box is held in place securely. I had a little bit left in a tube of super glue, so I just basically lathered it on and held it in place for 2 minutes until it was, set like a stone. And the theory is I just put the bottom cover back on and I'm away. I was just about to wrap this video up, but then I realised I'd made quite the oversight. And that is that this thing gives you an electric shock every time you unplug it if you accidentally touch these prongs. And I assume even if you left it on a shelf for a while and then poked them, you would still get the shock. And the reason for that is that power goes into the tool and then it sits inside the capacitors. It just sits and it waits. And there's nothing to drain it, because the old circuit would have had a resistor or two and they would have absorbed the power as soon as it was unplugged. Mine obviously doesn't have a resistor, so the plan, and you can already see them on the desk, is to just add 2 of these. I'll just put them directly inside the plug, because this is a UK plug. I can just take this screw out, I'll take it apart, and that way anyone who's working on this tool in the future will basically be able to see there are resistors in there. I've plugged the angle grinder in, and I've got the multimeter on the desk set to volts DC, and I'll just show you that it is working. So we'll get a beep when I do this. There we are, that's called continuity mode. I've got it set to volts DC, that's going to tell me how much power is stored, and what I'm going to do now is just unplug the angle grinder, put the socket on the desk and just measure across the pins. Right, so it's unplugged. A nice shock for me if I don't pay attention. It might just drain all the power out straight away, and if that happens, bad luck, but hopefully I can touch this to this. There you are, look, 60 volts for a moment there. It's stepping down now, it's 5, 4, 3, 2, 1. But the point is, that had current inside it. I've just drained it away, which, okay, great. But yeah, wouldn't it be nice if we just had some resistors absorbing the current instead, so that you don't absorb it into your fingers when you poke it? I've just taken the back cover off, as you can see. The plan is literally to just get 2 of these resistors, line them up so that the golden strip is at the same end for both of them. Now, in the real world it doesn't matter, but I might as well do it properly. I'm going to grab my pliers and just twist these up nice and tightly. Here we are, look. You can see that I've just put some heat shrink tubing over this and, as the name implies, shrunk it down. So this terminal is exposed here, and I'm going to put a bit over this piece. I'll bend it out straight, put the heat shrink tubing on, and then we'll be able to stick this inside the plug. Forgive me because I've jumped ahead a bit here, but I'm going to put this piece in here, look, and then I'm going to take a moment to just sort of, now that I have it in front of me, and kind of manipulate it and line it up the way that I need it to. Right, there we are. That's in a position I'm happy with. So I can remove this, I can bring the live conductor back, I can line this up in the receptacle, whatever you want to call it. I'll then line this piece up next to it, and I'll just screw them both down together. See what I'm talking about? So now you can see we've got this piece all the way in there, as well as the copper for the wire. So I can just hold this and this down together. I can then put this screw back, and these ones are always a bit fiddly because they aren't magnetic. But I can start it off, and then when I start it off I'll be able to tighten it the entire way down. Right, I really don't like slotted screws, they're very awkward, but hey. Somehow we've managed to make it work, so I'll tighten that down nicely. There we go, and that is in place now with the resistor. So then I can just bend the neutral into position, which I think I'm going to grab a pair of tweezers to do that with. But the idea is I'll put this in position, put that on top of it, tighten it down, and we'll be away. Here we are then. Take a look at that. I've put a nice 5 amp fuse in here. I've run this as neatly as I can. I reckon it's safe. I'm happy to use it anyway. I think that's pretty much that. If the 5 amp fuse ends up blowing due to the inrush current, I'll just replace it with the 13 amp fuse that was originally in there. It's back together, looking decent. So the plan is just to plug this thing in, and then I'm going to unplug it, and pretty much immediately I'm going to poke here, and we'll just see, won't we? We'll see if I get shocked. Right, I think that was long enough. I've unplugged it, and get ready. No shock. No shock at all. Working perfectly. So I would now argue that this tool, at the least, is as safe as it was when it came out of the factory, if not ever so slightly safer. If the people who built this want to come to my flat and start debating me, feel free. That's probably not going to happen. But no, this thing is now working exactly as it should, and most importantly, you don't get shocked when you unplug it. The only improvement I can think to make would be to 3D print a little sort of block that goes on here. You know, there'd be a small bit notched out just for this piece. But I'd 3D print something, it would have 2 screw holes there and there, so I'd super glue it on. I'd get some sort of a wire clamp, and I would just tighten this down to there, and then that way the wire isn't going to be bending around in here. But like I say, I'm only going to use this 2 or 3 times a year. I'm only going to use it a few minutes at a time. I'm really careful with my tools, so I'm probably not going to bother, but if you just wanted to make it perfect, then that's what you would do. There you go then, ladies and gentlemen. Take a look at that. It's working exactly as it should, and I'd argue it's just as safe as it was when it came out of the factory. I'm really pleased with it, you know? It only cost me £2.59 to fix, because that's all the resistors cost, and I've got an improv ray gun here. Isn't that cool? But in all seriousness, £2.59 is what stood between that and landfill, and in all fairness, someone who was daft enough to do it, because I could have just gone and bought a replacement and been on my merry way, and I would have spent way less time. But value isn't always just about time, because number one, I learned that I need to add resistors to a circuit like this. I didn't know that before, hence why I got a minor shock. And number two, it was fun doing it. Number three, you get a low to medium quality video out of it. And number four, some manufacturer who built cheap junk, well, sorry, but I'll fix your cheap junk, I'm going to carry on using it, boo-hoo, cry me a river. In all seriousness though, if you found this video useful, perhaps you saw something in it that you found, I don't know, funny almost, maybe a technique you're going to apply to your own work, then feel free to leave me a like. That would really help out. The more likes this thing gets, the more the channel grows. The more the channel grows, the more reach we have. The more reach we have, the more power we have to influence people and teach them that repair isn't something that's a complete waste of time, except for in this instance and in the monitor video. But usually it's not a waste of time. You learn new skills, and most importantly, you take money and you put it in your own back pocket. So instead of giving Dell £400 for a new laptop, you give a small business £20 for a part, you fix it, and then you take the £380 you were going to spend and you put it in your own back pocket. Right? Everyone needs more cash these days. Take the money, keep it in your own back pocket. Right? Anyway, if you want to see where this channel ends up going, because I'm hoping it ends up going somewhere, then feel free to hit the subscribe button. That too would really help me out. And it means that, for the most part, provided YouTube doesn't break, you know, you'll see the stuff that I upload as and when I upload it. The next video, I've said this a few times now, but I'm hoping it's going to be on 3 junk laptops that I've basically saved from waste and repaired. But either way, you're just going to have to stick around and see. But that's all I've got for you today. So until the next time, I will see you later. Take care for now, and goodbye.